This video looks at the area and circumference of a circle. So first of all, I'll talk about the parts of a circle. You have the center, which is equal distance from any point on the circle. So these are all points on the circle here. This forms a circle. So all points are equal distance from the center. A diameter runs from one side of the circle to the other. It's not really a side, but it runs through the circle, runs through the center, and intersects both 2 points on the circle. Let's put it that way. And a radius is half a diameter. A radius runs from the center to a point on the circle. Now notice that a radius, in fact, 2 times radius, and I'm going to let r represent radius, d equal diameter. 2 times radius, 2r equals d, and 1/2 a diameter is a radius. And then c stands for the circumference, which is one lap around a circle, or the distance around a circle. Or if this was a wheel, if I rolled it 1 revolution, that's how far. So if I had a wheel, if I rolled it 1 revolution, the distance it travels in 1 revolution when you roll it is the circumference of the wheel. So circumference of a circle, again, the diameter is a line segment that runs through the center and intersects 2 points on the circle, and a radius runs from the center to a point on the circle. And remember once again that diameter is 2r, or r is 1/2 of a diameter. So the Greek Archimedes is given credit for coming up with the best early estimate for a circle, for the actual Greek letter pi, which is defined to be the circumference of a circle divided by the diameter. And he did this by apparently finding the perimeter of a 96gon. Now here's a 20gon. A 20gon is a polygon. So for example, polygons would be a square, or a regular 4gon would be a square, I should say. A regular pentagon would be called a 5gon. A hexagon would be called a regular 6gon, etc. So he actually figured out the perimeter, that is the distance around a 96gon. He used that as an estimate for pi. And we will often use 3.14 to approximate pi right now. You can get much better estimates, but we'll use 3.14. So pi is equal to the circumference of a circle divided by its diameter. This also can be written as c equals pi times diameter. And since diameter is 2r, we can also write the formula c equals pi d, which I'm taking from right here. I can replace d with 2r. So that's pi times 2 times 2r, which is the same as 2 times pi times r. So these are our 2 formulas for the circumference of a circle. And both of them get used frequently. C equals 2 pi r and c equals pi d. These are formulas that need to be memorized. So now we'll derive the formula for the area of a circle. So what I'm going to do is I'm going to take a circle, I'm going to break it up into 8 equal parts, or 8 pieces of pi, and then I'm going to arrange these pieces of pi as follows. So I'm going to do this. So I'm going to arrange them up and down as follows. A little harder time than I thought. So this is going to be sideways, but I think you'll get the picture here. So now I'm going to turn this one upside down and fit it next to the 3 like so. Okay, then I'm going to take the next piece. That's piece 5. Actually, I want piece 5 here. Okay. hit it next to piece 4. And since you can't do this on your paper, you can just draw this. Mine is kind of crooked, so I'm going to copy it and lay it flat. So I'm just going to keep doing this process. Okay, so now I have this figure here, and I'm going to copy this. Okay, so now I'm going to take this figure and I'm going to draw it like this. Okay, so now let's just look at this. So this right here shall extend out. That is actually the radius of a circle, because that is from the center to a point on a circle. So this is my radius r. And then if you look at this figure, it looks just like it's very close to a parallelogram. So let's look at what this represents. So this is part piece 1, piece 3, piece 5, piece 7. So let's go back to our original circle. So this is piece 1, piece 3, piece 5, and piece 7. So every other piece of the circle is in green here. And the distance around the circle, that's the circumference. So since half the pieces are marked, that means this 1, 3, 5, and 7 must be half a circumference. So the length of these arcs here has to be 1/2 of the circumference of a circle. So now this is approximately a parallelogram, and the area of a parallelogram, recall from previous videos, is base B times height h. Well, in this case, my base is approximated by 1/2 c, and my height is r. Okay, but c, remember, is 2 pi r. So what I can do here is I can substitute c with 2 pi r. So I have 1/2. Replace c with 2 pi r, making this substitution here for c because they're equivalent, times r. So I'm bringing down the r, bringing down the 1/2. So I have 1/2 times 2 pi r times r. Now we can simplify this. 1/2 times 2 is 1. 1/2 of 2 is 1. Times pi times r times r. But r times r is r to the second. So my area formula is going to be pi r squared. Now the reason this works is, imagine if I had a circle that was 1,000,000 pieces. As I increase the number of pieces, this lumpiness is going to go away, and in fact I'm going to approach what is an actual parallelogram. So as the number of pieces goes to infinity, the area of the parallelogram will in fact become the area of a circle. So the area of a circle is pi r squared. It's an important formula that should be memorized. Now you could write, it's not used as often, but you could write that formula for area in terms of a diameter. So we know now that A, the area of a circle, is pi r squared, and we know that r equals 1/2 d, because we said this earlier, but diameter is 2r, so r has to be half a diameter. So I could make a substitution here For r, replace it with 1/2 d, and then I'm going to square that. So I'm making the replacement here of r with 1/2 d, and then this is the same as pi times 1/2 d times 1/2 d, because 1/2 d quantity squared is 1/2 d times 1/2 d. Well, 1/2 times a half is a fourth, so I have pi times 1/4 d squared. So my formula can become 1/4 times pi d squared. This is another way to express the area of a circle, but it's not as common. The one we almost always use is pi r squared. It's usually just easier to convert the diameter to a radius and use this formula than use this one. Okay, so now let's find the area and circumference of a couple circles. So in the first one here, I have a radius. My r is equal to 4. Remember that c is 2 pi r. So c is 2, and I'm going to use 3.14 to approximate pi. So replace pi 3.14 times 4. Well, this is 2 times 4 is 8, and 8 times 3.14 will give me my circumference. So 3.14 times 8 is going to be moved decimal point 2 places, 25.12 inches. Okay, then the area, A is pi r squared. So we'll use, and this is approximately equal to here because I'm making an approximation. I'm using 3.14 for pi. That's not the exact value. So here, this is going to be approximately equal to 3.14 for pi, and then r is 4. That's 4 squared. Well, 4 squared, remember, means 4 times itself twice, which is 16. It's not 2 times 4. Okay, so this is 16. So this is going to equal 3.14 times 16. So do the math. Add a placeholder 0. That's second row. That's 4 times 1, 1 times 1, 3 times 1. So move decimal point 2 places. That's 50.24 square inches. So it means in the area I could fit 50.24 little squares that are 1 inch by 1 inch in measurement. So for the second circle, I'm given a diameter. I think it's just easy to split the diameter in half. So since D is 12, that means R is half of 12, so it's 6 feet. So circumference is 2 pi r. So I'm going to replace, that's approximately equal to 2 times, I'm going to replace pi with 3.14 and replace r with 6. So then this is 2 times 6 is 12 times 3.14. So if I take 3.14 times 12, do the math, add a placeholder 0 here, that's 4 times 1, 1 times 1, 3 times 1. Move decimal point 2 places to the left, that's 37.68 inches. So if I roll this circle 1 revolution as a wheel, it would go 37.68 inches. Okay, then the area is pi r squared, which is approximately 3.14 times 6 squared. Well, 6 squared is 6 times 6, which is 36. So this is 3.14 times 36. So to finish out, I'm going to do the math here. 3.14 times 36. That's 24. Carry a 2. 1 times 6 is 6, plus 2 is 8. 3 times 6 is 18. Add a placeholder 0. 4 times 3 is 12. Carry a 1. 1 times 3 is 3, plus 1 is 4. 3 times 3 is 9. Add up the columns. 8 and 4 and 1 is 13. Carry a 1. 1, 1, 9 is 11. So now move decimal point. That's 36 here, so that is move it 2 places. There's 2 places total behind the decimal point, so I move it between a 3 and a 0. So my final answer is the area here is 113.04 square feet. And that should have been feet in this one also, because units were feet. Okay, so that means inside the circle, I could fit 113.04 little squares that are 1 foot by 1 foot in dimension. And this concludes the video.